Hello and welcome, students. This is a lecture on vectors, and in last lecture I had taught you the details about the scalar triple product of three vectors. And in this vector we are going to take few problems on scalar triple product. So here in this question, what do you notice? They say find a bar dot b bar cross c bar. See, you have to find the scalar triple product of a bar, b bar, c bar. They give you the vectors a bar, b bar, and c bar. Okay, I know how to find the scalar triple product with the help of determinant. So I will begin with my answer. See, here I have a bar dot b bar cross c bar equals to, what I will write? It is equal to mod of what is a bar? A bar is 3 I cap minus j cap plus 4 k cap. So you can write 3 minus 1 4. B bar is 2 3 minus 1. See, I will write the coefficient of I cap j cap k cap in second row, as I wrote for the coefficient of I cap j cap k cap of a bar in the first row. Then C bar is, so I will write minus 5 2 and 3. Now I will evaluate the determinant. So what is it equal to? It is equal to 3 times, 3 times you ignore this row and this column. So what you are left with is the minor. Okay, you will find out the value of this minor determinant. What is it? It is 9 minus of minus 2. Got that? So you get here 9 minus minus 2. So 3 into 9 minus of minus 2 plus 2. Then you will go for minus 1. You will change the sign here. So plus 1. And what you have, you ignore this row and this column. So you are left with 2 minus 1 minus 5 3. So it is 2 into 3 minus of minus 5 into minus 1. So you get here 6 minus 5. See, minus 5 into minus 1 is plus 5. So 6 minus 5. Okay. Then you have plus 4, and you ignore this row and this column. So what do you have? You have 4 minus of this. So what do you get? You get here 4 minus of 4 into 4 minus of minus 15, that is plus 15. So what do you get? You get 3 into 11 plus 1 into 1 is 1 into 1 is 1 plus 4 into 19. So this is 33 plus 1, and 19 fours are 76. So you got here 77 plus 3 is 80. 110 is what you are getting for a bar dot b bar cross c bar. I hope you followed it. So now we have third question here. The third question is another question, see, from same exercise based on the scalar triple product of three vectors. It says if the vectors minus 3 I cap plus 4 j cap minus 2 k cap, I cap plus 2 k cap, I cap minus 3 j cap are coplanar. These three vectors are coplanar, then find the value of P. See, students, we know that if three vectors are coplanar, then the scalar triple product of those three vectors will be equal to 0. Okay, so if you are solving this problem for some entrance exam, you don't have to write much in detail. You will just write the determinant and you will equate it to 0, and that's you will solve that determinant, you will get the value of P. But when you are solving for your board exams, then you will have to be a bit elaborative. So you will write let a bar equals to this, minus 3 I cap plus 4 j cap minus 2 k cap. B bar equals to this vector, I cap plus, see, there is no j cap, means 0 j cap. You see this, plus 2 k cap. Then you have C bar. What is C bar? I cap minus p j cap plus 0 k cap. Okay, now I will write, since A bar, B bar, and C bar are coplanar vectors. They are coplanar vectors. And we have done this in the property. When three vectors are coplanar, therefore, what you will have, box of A bar, B bar, C bar will be equal to 0. It will be equal to 0. What does that mean? It means the determinant that you will get, it will be equal to 0. So now get the determinant. Negative 3, 4 minus 2. Okay, negative 3, 4, negative 2, 1. See, 1, 0, 2, 1, 0, 2. And here you have 1 minus P, 0. This will be equal to 0. Now I shall go for the expansion of this determinant. The value which I will get, it will contain P in that, and we will solve it accordingly. So it is negative 3 into, see, I have negative 3 into 0 into 0 is 0 plus 2P minus 4 into 0 minus 2, 0 minus 2, minus 2 into, I get minus P minus 0, minus P minus 0 equals to 0. So here I have negative 6P, this is plus 8 plus 2P equals to 0. So this gets me minus 4P equals to minus 8. So I get P equals to 2. This is the answer. P is equal to 2. So now let's move ahead. See here, we have two questions where we have to prove left-hand side is equal to right-hand side. Not to be said, these questions are also based on same concept, that is concept of scalar triple product. Look at the first question. They are very simple questions, but yes, you will need the algebra of vectors. That is, you will need the distribution of cross product over sum, the distribution of cross product over difference, then the same for the dot product, that is distribution of dot over sum and dot over difference, which we have done initially when I had started with the topic of vectors. Okay, so here I have two questions, very simple questions, at the same time very important. See, the first one is, it says to prove that the scalar triple product of A bar, B bar plus C bar, see, this is A bar, B bar plus C bar, and A bar plus B bar plus C bar is equal to 0. It is equal to 0. So see, how do I go ahead? I will start with left hand side. So I'll write here left hand side. Left hand side is A bar dot B bar plus C bar cross A bar plus B bar plus C bar. Okay. See, this is how you write. How do you write? If I say, if I ask you the box product of P bar, Q bar, and R bar, what will you write for this? You will write it P bar dot Q bar cross R bar, right? P bar dot cross of these two. I've done the same thing. A bar dot cross of these two vectors. I have done the same thing. I hope you all are following this. Now, the next thing that I will do here is, see, students. Okay. So one thing is very important here. See, one thing I want to make it very clear, that when I have the box of three vectors like P bar, Q bar, R bar, okay, then I will write it as P bar dot Q bar cross R bar, right? This is by definition. At the same time, remember, if I'm given P bar in terms of I cap, J cap, K cap, Q bar as a linear combination of I cap, J cap, K cap, and R bar also in the linear combination of I cap, J cap, K cap, I can write the scalar triple product also as a determinant. I can also write it as determinant. So both are equally true and they are equally being used whenever required. So here I'm going for this one. Okay, A bar, because I don't have these vectors in I cap, J cap, K cap form. So here, next step, see what I get. I will get therefore C A bar dot, and you know what next I'll do? I will distribute. See, this is a vector. This is a vector. B bar plus C bar is a vector. Yes. You have cross with this vector. Yes. Now in this vector, what you notice that you have A bar plus B bar plus C bar. So you know what we are going to do? We will distribute cross over sum. So see, B bar plus C bar cross A bar, B bar plus C bar cross B bar plus C bar cross C bar. This is known as distribution of cross over sum. See, here you have plus sign. So distribution of cross over sum. This is what we are going to do. So see, what do I get here? I will get here, see, I will get here B bar plus C bar cross A bar plus B bar plus C bar cross B bar plus B bar plus C bar cross C bar, and the bracket is closed. Now what I do next? Once again the same thing. Now, but this time it is from the right. See here. I will distribute once again cross A bar over sum. So see, what will I get? But remember, when you are distributing from the right, remember cross product is not commutative. So you will have to maintain the order. Okay, you'll have to maintain the order the way it is. So you will write the B bar cross A bar and C bar cross A bar. This time you are once again distributing the cross over sum, but this time the distribution is from the right. From the right. Here it was from left. I hope you are getting it. So next step, what I get here is, the next step that I get here is, it is A bar, and you have B bar cross A bar plus C bar cross A bar plus, now I'll go for this one. See here, this is being distributed. So in the next you'll get your B bar cross B bar plus C bar cross B bar plus B bar cross C bar plus C bar cross C bar. Okay. Now in this, I notice, students, that B bar cross B bar and C bar cross C bar will be 0 bar. Why? Because the cross product of a vector with itself is 0 vector. Okay. So here I will have this and this 0 bar. Okay. Further, look at this. Look at this one. This is C bar cross B bar, and here I have B bar cross C bar. For C bar cross B bar, can I write B bar cross C bar? Yes, but you'll have to write negative. See, C bar cross B bar is negative of B bar cross C bar. See, cross product is anti-commutative. It is known as anti-commutative. In dot, what you say, see, if it was a dot product, then you would have said C bar dot B bar is equal to B bar dot C bar. In dot product, the order, if you change, doesn't matter. They are still equal. But in cross product, if you change the order, you will have to put a negative sign. That is why you say that cross product is anti-commutative. Okay. So here what you have, so next step, see what I write. I write there for next step as A bar dot, this here I will write B bar cross A bar, okay, plus I will write here C bar cross A bar plus 0 bar, this is 0 bar, and this is C bar cross B bar minus B bar cross C bar plus B bar cross C bar plus this is also 0 bar. Okay, now see in the next step what will happen. See, these two are gone, this is gone with this. Okay, these two are gone. So what is next step you get? You will get therefore A bar dot B bar cross A bar plus C bar cross A bar. Okay, so here here you will write the reasons that you have used here. So you will write B bar cross B bar is equal to 0 bar, and you will write C bar cross B bar is equal to minus B bar cross C bar. You will write this here. Okay. This and this. Okay, so we have arrived at this. Now it comes the distribution of dot over sum. See here, students, look at this. This is one vector. A vector cross vector is a vector. A vector cross vector is a vector. And I have got a plus sign in between them. I've got a plus sign in between them. Outside, I have a dot product. So see here. This is a vector. This is a vector. Vector plus vector. You see this? Vector plus vector is a vector. And I have got a bar dot this vector. You got that? So what will I do now? I will go for the distribution of dot over sum. See, this is one vector, this is another vector, and in between I have plus sign. I will distribute dot over plus. So a bar dot this vector plus a bar dot this vector. Okay. So let us now do that. So I go for, in the next step, see what I write. Okay, first let me make the compartment. Okay, so it is in the next step, I will get a bar dot b bar cross a bar dot b bar cross a bar plus a bar dot c bar cross a bar. Okay, a bar dot c bar cross a bar. Now tell me, students, is this not the definition of scalar triple product? Yes, it is. So how will I write a bar dot b bar cross a bar? I will write this as a bar b bar a bar. Okay, and plus here, how will you write? You will write a bar c bar and a bar. Okay. Now here I understand that the value of this scalar triple product will be 0. Why? Because we know when any two vectors from the three vectors are equal to each other, the scalar triple product value is 0. And here also it is 0. See, a bar and a bar are equal vectors. Here also the same. So the final answer is 0, which is equal to RHS. Hence proved. Hence proved. I hope you followed it. Very simple, at the same time, very, very, very important. So students, now we'll go for the second one. See, we will prove the second one. Okay, second one is slightly bigger in the length. The solution is slightly bigger, but then idea will remain the same. The idea will remain the same. Okay, so let's begin. I will start with the left hand side. What is left hand side? The left hand side, I will write the second. I will begin with the left hand side, which is a bar plus 2b bar minus c bar, a bar plus 2b bar minus c bar dot, and here I have a bar minus b bar cross a bar minus b bar minus c bar. This is my left hand side. This is my left hand side. Okay. So what is important here, students? Please understand that how is this problem different from the earlier problem? See, in the earlier problem, they had given us the left hand side as the scalar triple product, but in the form of a box. You see this? They had given us a scalar triple product, but in the form of a box. What I mean is, they had given us inside a box a vector, second vector, and the third vector, which I wrote as first vector dot second cross third. You got that? But in the second question, you know what? They are giving us once again scalar triple product, but not in the form of a box. You see this? This time they are not giving us in the form of a box. Instead, they are writing the first vector dot second vector cross third vector. It is they are not giving us in the form of a cross. These small things, if you understand, you solve the questions better. You solve the questions better. So here, if if you want to write the second question, if you want to write the second question like the first question, you know what? Then the second question, if the left hand side of the second question you want to write like the first question, then it will be inside the box a bar plus 2b bar minus c bar, then a bar minus b bar, and a bar minus b bar minus c bar like this, okay, equal to 3 times a bar minus b bar minus c bar. See? They could have written even like this. See, the question can even be put this way. You understand? The question can even be put this way. This could also be the left hand side. I hope you are getting it. So this is my left hand side. What will I do next? I will distribute the cross over difference. This time we have minus sign. So see, a bar minus b bar cross a bar minus a bar minus b bar cross b bar, and a bar minus b bar cross c bar. So this is distribution of cross product over difference. Okay, so outside bracket, you will keep it as it is. So in the next step, you get a bar plus 2b bar minus c bar dot, you have a bar minus b bar cross a bar minus a bar minus b bar cross b bar minus a bar minus b bar cross c bar. Now once again the distribution, but this time it is from the right. So this way it will come, okay? So here I have next as, the next one I will get as a bar plus 2b bar minus c bar dot c. You will get here a bar, you will get your a bar cross a bar minus b bar cross a bar minus a bar cross b bar. Now I have come to the second one, okay? It is from the right, so you'll maintain the order, a bar cross b bar. Then you have minus minus plus b bar cross b bar. Then you have minus a bar cross c bar plus b bar cross c bar. You know that the cross product of a vector with itself is 0. So this a bar cross a bar and b bar cross b bar will be 0. Further, you know that b bar cross a bar, you know that b bar cross a bar, you can write minus of a bar cross b bar. Okay. So when you write this as a bar cross b bar, you will put a negative sign. Now that negative and this negative will become positive. Okay. So here, in the next step, what I write, I will write the outside bracket vector will remain as it is, a bar plus 2b bar minus c bar dot, here you will have 0 bar minus of a bar cross b bar. You see what I did? Negative, and for this I'm writing minus a bar cross b bar. Okay, minus of a bar cross b bar. Then this is minus a bar cross b bar. Okay, and here you have once again b bar cross b bar is 0 bar, and this is minus a bar cross c bar plus b bar cross c bar. Okay, now see next step. So this is a bar plus 2b bar minus c bar dot. Now see, wherever 0 bar you have, you can just ignore it, because adding or subtracting 0 bar to any vector will get you the same vector once again. Now this is, here you have minus of minus become plus. So a bar cross b bar minus a bar cross b bar minus a bar cross c bar plus b bar cross c bar. This is what you get. Now in the next step, these two cancel, a bar cross b bar and minus a bar cross b bar, these two cancel. Okay, these two vectors cancel. So you have the next step as, see outside you have this vector. So you have a bar plus 2b bar minus c bar dot inside the bracket. See, you have minus a bar cross c bar plus B bar cross C bar. I will write this vector first and this as negative vector, so I'll write it second. Okay. So see, I write B bar cross C bar minus A bar cross C bar. This is the way I write it. Now what is next step? See, you have a vector here. See, you have a vector here. Vector cross vector. B bar cross C bar is a vector. A bar cross C bar is also a vector. So you have a vector minus vector, and outside you have vector. So see, it is the dot product of this vector inside the bracket with this and this. So it is, you will distribute dot over difference. So this, okay, you will distribute dot over difference, and that will be the final step. So here, you know, you will have A bar plus 2B bar minus C bar dot B bar cross C bar minus again A bar plus 2B bar minus C bar dot A bar cross C bar. Okay, see the next step. Once again, we have distribution, this time distribution once again, but this time the distribution is from the right. See, dot B bar cross C bar. Here you have dot B bar cross C bar, and here you have plus and minus. So you will distribute like this. You see this? You will distribute the vectors from the right. Okay. So what do you get? You will get here. You will get here A bar. Okay, I'm using another color. So you'll get your A bar dot B bar cross C bar plus 2B bar dot B bar cross C bar minus C bar dot B bar cross C bar. Okay, then you have this thing. Okay. Okay, I'm using another color for that in order to maintain distinction. Okay, so I write a negative sign. See, this negative I wrote there, and then I'll put a bracket because inside I'm going to get several plus minus. So distribute this dot over this bracket. So what will it get you? It will get you now. It will now get you A bar dot A bar cross C bar plus 2B bar dot A bar cross C bar minus C bar dot A bar cross C bar. You see this? And the bracket is closed. Now I go for, see, I go for now next step. See, the next step, what do I? So see here, LHS once again. See, I'm still doing LHS. What is this? See, this is box of A bar, B bar, C bar. This is A bar dot B bar cross C bar. This is A bar dot B bar cross C bar. So that is box of A bar, B bar, C bar. So see here, you get A bar, B bar, C bar. Got that? Yes. Look at this. Look at this here. What is this? This is 2B bar dot B bar cross C bar. So this is plus, you have plus box of 2B bar, B bar, C bar. Yes. Then you have minus. Next, look at this. Next, you have C bar, B bar, C bar, B bar, and C bar. Then now open the bracket. Open the bracket. So see minus. What do you have? You will have minus. Okay. Minus A bar, C bar. Okay. Again minus. This plus becomes minus. Minus. What do you have? Minus. You will have 2B bar, A bar, C bar and plus C bar, A bar, C bar. Now see students, in these box products, following box products are going to be zero. So this will be zero. Why? You know when two vectors are collinear to each other in three vectors. See, 2b bar and b bar, they are collinear to each other. Why? Because this vector is a scalar multiple of b bar. 2b bar, 2 times b bar. So it means 2b bar and b bar, they are collinear to each other. When two vectors are collinear, the value of the scalar triple product is 0. This is going to be 0. Further, see, this will also be 0. Why this is 0? Because inside a in a scalar triple product, when two vectors are equal, any two vectors are equal, the scalar triple product is 0. So see, C bar, this will also be 0, and this will also be 0. So these four vectors, these four scalar triple products are going to be 0. So in the next step, what I'm left with, so the next step I get equal to, see, I have only A bar, B bar, C bar, okay, minus, and see, I have this vector. I have this scalar triple product. So minus, let me take this 2 out. I have taught you the property. This property has already been done. You remember what property? The property was if you have A bar, MB bar, C bar, where M is a scalar, so this M can come out. It will be equal to M times A bar, B bar, C bar. This was the property. So this property, when I use this 2, which is a scalar, multiplied to vector B bar, what can I do? I can take that 2 out. So when 2 is out, I get here B bar, A bar, and C bar. In the next step, what I do is, look at this. Here, this is A bar, B bar, C bar. This is A bar, B bar, C bar. Yes. And here what I notice it is B bar, A bar, C bar. So if I interchange these two, I will put one more negative sign. That negative with this negative will become positive. The negative with negative will become positive. So this will become plus 2 times A bar, B bar, C bar, plus 2 times A bar, B bar, C bar. So what is this equal to now? It becomes equal to 3 times A bar, B bar, and C bar. This becomes equals to 3 times A bar, B bar, C bar. I hope you followed it. See this, when I interchange, it will become A bar, B bar, and C bar, right? Which is equal to, now this is A bar, B bar, C bar plus 2 times A bar, B bar, C bar. That will become 3 times. A bar, B bar, and C bar. Okay. This is my left hand side, which I got. And what is the RHS? What is RHS? Let me now work on RHS. See, the RHS here is, I will write RHS here. See, what was RHS? RHS was 3 times A bar minus B bar minus C bar. Okay. RHS is, I now write RHS. RHS is equal to 3 times A bar minus B bar and minus C bar. But as you know, students, I can take this minus 1 and minus 1 outside. So minus 1 into minus 1 is plus 1. So this is 3 times, which is equal to 3 times box product A bar, B bar, C bar. See what I'm doing? This minus 1 is a scalar. B bar means minus 1 times B bar. Minus B bar means minus 1 times B bar, and this is minus 1 times C bar. So that minus 1 and this minus 1 I can take outside the scalar triple product. And what will happen next? Minus 1 into minus 1 is plus 1. So in the next step, I get this. So now LHS and RHS are equal. So we will write therefore LHS equals to RHS. Hence proved. I hope you followed it. This one was a nice question. You can practice it. The practice is important. If you know, this is easy, very easy, but you need to have the practice. So in question number 5, we are given if C bar is 3A bar minus 2B bar. C bar is 3A bar minus 2B. That is, C bar is a linear combination of A bar and B bar. So as such, students, when you know that whenever one vector can be expressed as a unique linear combination of other two vectors, then those three vectors are coplanar vectors. Those three vectors are coplanar vectors. Now see, when they give me that C bar is 3A bar minus 2B bar, this is enough. This is enough. This is sufficient for me to understand that A bar, B bar, and C bar are coplanar vectors. So if they are coplanar vectors, it has to be 0. As such, it has to be 0. But if I have some MCQ kind of problem, so I know the answer directly that it is 0. But here, they want us to prove it. Now, since they want us to prove it, we will do it slightly differently. See here how I will begin my answer with. They give me C bar as 3A bar minus 2B bar, and I have to prove that the box product is 0. So I will go for LHS. See, what is LHS here? LHS here is A bar box of A bar. LHS here is box of A bar, B bar, C bar, right? So that is equal to A bar dot B bar cross C bar, right? Now I shall substitute what C bar is. So here I will write A bar dot, okay, B bar cross. And what is C bar? C bar is 3A bar minus 2B bar. Now, once again, what I taught you earlier in the earlier two problems, you will distribute cross over difference. You will distribute cross over difference. So the next step that you get is A bar dot, inside the bracket, you get B bar cross 3A bar, okay, minus you get B bar cross 2B bar. Now see, B bar cross 2B bar will be 0. Why? Because, see, this will be 0. This whole thing will be a 0 vector. It will be 0 bar. Don't write simply 0. It is cross product. Cross product is always a vector. So you will write 0 bar. Why this is 0 bar? Because B bar and 2B bar, they are B bar and 2B bar, they are collinear vectors. See, 2B bar is a scalar multiple of B bar. So B bar and 2B bar are collinear vectors. So in the next step you get, so you get here A bar dot B bar cross 3A bar, A bar dot B bar cross 3A bar minus 0 bar, minus 0 bar. So what you will write? You will write A bar dot B bar cross 3A bar, right? This is what you get, A bar dot B bar cross 3A bar, which is equal to A bar B bar 3A bar. Now once again, this is equal to 0. Why? You understand that vector A bar and vector 3A bar, they are collinear vectors, and you know that scalar triple product, if any two vectors are collinear vectors, the scalar triple product is 0, which is equal to RHS, hence proved. Hence proved. So here we have one more question. See, question number 6. It says if U bar is I cap minus 2J cap plus K cap, R bar is 3I cap plus K cap, and W bar is J cap minus K cap are given vectors, then find the vector, then find the scalar triple product. This is a scalar triple product. How do I know? See, because I have U bar plus W bar. See, look at this, observe it. U bar plus W bar is a vector. Yes. Then you have a dot product of, see, you have dot product of this vector with the cross of these two. See, look at them. This W bar cross R bar, vector cross vector is a vector. R bar cross W bar is a vector. There was a correction in the question. Here it was not W bar, it was U bar. Okay. So what I have U bar plus W bar, which is a vector. Then I have U bar cross R bar. See, the cross product of two vectors is a vector, and R bar cross W bar, which is also a vector. So now what I have? See, I have I have this vector, which is, can I take this vector as A bar? Can I consider this vector as A bar? Take it as A bar. So you have A bar dot. Now see, take this vector as B bar cross and take this vector as C bar. See what you have? You have the scalar triple product. See, this is scalar triple product. Okay, but these these vectors u bar, r bar, and w bar, they also have been given as a linear combination of I cap, j cap, k cap. So what we will do, we will first go for these vectors, like we will find u bar plus w bar, u bar cross r bar cross w bar, and then we will substitute them here. Okay, so let's begin with problem solving. So here I have, see, I will write, my solution will start here. I will write here u bar plus w bar equals to, you're going to add this vector with this vector. What do you get? You get 2 I cap. I cap plus I cap is 2 I cap. I'm sorry. This is not, there is no I cap here. There is no I cap here. It is j cap minus k cap. So you have 0 I cap here. So I cap plus 0 I cap is I cap. See, you have to be very alert. Such mistakes are quite common. So I cap, and then see, you have minus 2 j cap plus j cap, that is minus j cap, and then plus k cap minus k cap, that is 0 k cap. So this is what you get, plus 0 k cap. Even if you don't write 0 k cap, it is okay. So you got u bar plus w bar. Now you will go for u bar cross r bar. So see here, this is first one. This is first one that I got, u bar cross r bar. I'll go for u bar cross r bar. And for this, I will use the determinant, this cross product. So I cap, j cap, k cap. Then I'll write the coefficient of I cap, j cap, k cap for u bar in the second row. That is 1 minus 2, 1, 1 minus 2, 1. And then for r bar, I will write 3, 3. See, there is no j cap, so it is 0 j cap, 0 and 1. I will calculate this. So this gets me I cap into minus 2 minus 0 minus j cap minus j cap. I get 1 minus 3 plus k cap, and I get 0, 0 minus of minus 6, that is 0 plus 6. So what I get minus 2 I cap plus 2 j cap plus 6 k cap. This is, I get u bar cross r bar. This is number 2 that I got. Now I go for r bar cross w bar the same way. I go for r bar cross w bar. I'll go for the determinant. What is it? It is I cap, j cap, k cap, I cap, j cap, k cap. I write the coefficients of r bar. I write the coefficients of I cap, j cap, k cap for vector r bar in the second row. So what is r bar? R bar 3, 0 and 1. You write 3, 0 and 1. And the w bar, you write 0, 1 minus 1, 0, 1 minus 1, negative 1. So this gets you now I cap and 0 minus 1, 0 minus 1 minus j cap gets you minus 3 minus 0 and k cap plus k cap gets you 3 minus 0. That is minus I cap plus 3 j cap plus 3 j cap minus I cap plus 3 j cap plus 3 k cap. This is number 3. Okay. Now I can find what I'm asked to find. I can go for it. So here, so I get here, therefore u bar plus w bar, okay, dot u bar cross r bar cross r bar cross w bar is equal to, what is it equal to? You know, it is nothing but the scalar triple product of u bar plus w bar, u bar cross r bar cross w bar. This is nothing but this, the scalar triple product, which is equal to the determinant. I have already found these three. Vectors. So I'll write their coefficient. I'll write the coefficients of I cap, j cap, k cap of these three vectors here. So u bar plus w bar, what is it? It is 1 minus 1, 0. 1 minus 1, 0. U bar cross r bar. Here it is. See, here it is. It is minus 2, 2, 6. Minus 2, 2, 6. And this is minus 1, 3, 3. Let's solve this. So you get here 1 into 6 minus 18, 6 minus 18 plus 1 into minus 6 plus 6 plus 1 into minus 6 minus of minus 6, that is plus 6, plus 0 into this into this minus this into. You know, 0 into anything is going to be 0. So you have minus 6 plus 2. So this is minus 12. Minus 6 plus 6 is 0. Plus 0 plus 0. So the final answer is minus 12. This is the final answer. I hope you followed it. You can copy this down.
Fine, sir. Thank you, sir.